Hello, welcome back to another version of Mr. Wernau Does Your Homework for you. We're going to take a look at a few questions from the homework and how we can use Desmos to help it. Now, you should be writing these on your own sheet of paper, but I'm going to go ahead and do these on my canvas, on my notes here. So the first question says the position of a particle at time t seconds, where t has to be greater than or equal to 0. We're taking a look at question number 2 here. Given by the position function, t squared minus sine of t from 0 to 3. We want to find the particle's acceleration each time the velocity is 0. Now notice they gave us position. So we know to get velocity, I do have to take the derivative, and I'm going to go ahead and do that. So the derivative of my position is simple. That's just 2t minus cosine of t. And that's where I'm going to stop doing any work in terms of by hand, because everything else I'm going to do on Desmo, because if we were to graph our velocity function, and we're going to graph it, call it f of t equals 2t minus cosine of t. I'm going to graph that. And we want to find the particle's acceleration when the velocity is 0 on 0 to 3. So if we notice on the, sorry. If we notice on the graph between 0 and 3, we only cross the x-axis at one point. And that's where I want to find. So remember, this is my velocity graph. So I know the velocity at 0, and I can just rest on that little gray dot. The velocity at 0, the x-axis, or the velocity is 0 on the x-axis occurs at 0.450. What I want to do now is I want to find the acceleration. So my velocity is not v of 0, that's where I get messing up. There we go. My velocity is 0 when t equals 0.450. I'm going to hear some comments on that one. Hope make them nice. I do cry when I read them. So, so we know our velocity is 0.450 seconds. Sorry about that. So now we want to find the acceleration. Well, to get the acceleration at 0.450, we just have to look at the derivative of velocity at 0.450. And since we've already graphed our velocity function, if we go back up here to get the derivative at 0.450, all we have to do is do f prime of 0.450. And notice we get this 2.35, 2.435, 2.435. Now we're told meters in seconds, so this would be meters per second. Now, all told, this question should take you about a minute. I know I messed up there a little bit at the beginning, and I apologize for you in that one. All right, so let's take a quick look at question number 3 now. Here we're told a particle's velocity is given by this cosine t squared plus 4t, where t is measured in seconds, and again, v is measured in meters per second. We want to find the velocity every time the acceleration is 0. Well, so I'm going to go back over here and graph my velocity curve. Remember, we always want to graph velocity. Velocity is where it's at, because the slope of velocity is my acceleration. And I know the area under the curve later on is going to give us our displacement, which gives us position later on. So I am always going to graph my velocity function. We have to call it f of t because of Desmos rules, but that's okay. And this becomes plus t. And there it is. Now we want to only look between 0 and 4. So I'm going to kind of see if I can fit that in my little window right there between 0 and 4. So if I want to find out where the acceleration is 0, which is the slope of velocity is 0. So what I need to look for are the max and mins. That's it. This is my velocity curve. So if I go over here, tap on the green thing, and every time the slope is 0, that is a place where the acceleration is 0. And that's also telling me when giving me the velocity at that point. Oh, hello. Kind of froze there for, there we go. So we can find all of these points right there. And we just type them all in. Now there's a bunch of them, so I'm just gonna name a couple here. You can get the idea. So the first one, let me go zoom in here real quickly, occurs at 8.14. So we can say the velocity at 0.814 is this 1.60. There's one. My next one down here, the velocity at 1.685, that is 0.737. So I just named two of them. And every time we're here, this is where the velocity is zero. We just have to name 1, 2, 3, 4, 5, 6. And there's one more up here. But that was it, just six. Those 6 points. We'd have 1, 2, 3, 4, 5. Those 5.67. There we go. Those 7 points right there. Takes a while to write out. But again, not very difficult to do, especially with Desmos. All right. So let's take a look at another question here real quick. This is an easy one. This is an easy one. This is one came straight out of the AP exam. A particle is moving along the x-axis, so they give us the following velocity, natural log of 1 plus 2 to the t. We want to find the acceleration. This one should take you about 30 seconds. So we can type it in. F of t equals, this is the natural log of 1 plus 2 to the t. Now, we don't know how to take this derivative yet, so this is definitely a good Desmos question. I want to find the acceleration. Remember, the acceleration at 3 in this case is the derivative of the velocity at 3. So all I have to do is go to Desmos and just type in f prime of 3, and I get my answer, 0.616. There it is, 0.616. And there's our answer. That's how hard these are. Right, let's take a look at the ugliest question you'll ever see in your life. Okay, question number 6. It says the velocity is this 1 minus inverse tangent of e to the t. Talk about a negative, a terrible, terrible, terrible derivative to take. This one is definitely calculator. So we want to find the acceleration. So the first thing I'm going to do, I'm always going to graph velocity. We always graph velocity. 1 minus the tangent, and you can do inverse of e to the t. And there it is. There's our function right there. And for the first question, we just want to find the acceleration. So I'm going to do this up here, okay? You can see my work up here. So for part A, I want to get that acceleration at t equals 2. So to get the acceleration at 2, that's just the derivative of the velocity at 2. And I'm just go down over here. Oh no, I deleted it. So let me go type that back in here real quick. Wish they had a undo button on this one. 1 minus tangent inverse is caret -1 e to the t. There it is. And I want to just find the derivative at 2. So I'm just go f prime of, not double prime, f prime of 2. And I get this negative 0.133. And there it is, negative 0.133. That's all it takes. For part B, it says if this is the speed of the particle increasing or decreasing. So remember, for speed, we need the velocity at 2 and we need the acceleration at 2. Well, we already have the acceleration. It's negative 0.133. To get the velocity at 2, I keep deleting it. So let me type it in again. F of t equals, just type that in again, 1 minus, hopefully you will not have the same issues I am having, to the -1. I'm getting really good at typing this question in. And I'm that, so there's my velocity graph. So remember, we already found the derivative at 2. I just need to find the value at 2. That's my velocity. And it's also negative. It is this negative 0.436. 6. So notice they are the same signs. So we would say that the speed is increasing because of the same time. Remember, speed, to increase your speed or speed up, your velocity and your acceleration have to be the same signs or same direction. So we would say the particle is speeding, or the speed is, I guess we should say the speed is increasing. Let's use the language they use. Because the velocity at 2 and the acceleration at 2 are the same signs right there. And now we're going to take a look at a very unique question. Question C. So I'm going to move all of this up, right up there. Question C. Question C says, find the time greater than 0 when the particle reaches the highest point. So for this one, this would normally be a candidate's test. So let's go and set this up. Furthest to the highest height. So we want to find out where the velocity is 0. And I can find that right over here. If I go over my graph, I can just touch where it crosses the x-axis, plug that as a point, and it occurs at 0.443. So it's at 0.443. That's the time for it. So I am going to try to do candidates test because I'm looking for the highest point. But here's the problem. I'm given velocity, but are we ever given a position function? And the answer is no. So this is one of the very few times where the candidates test fails because we can't find the position yet. Now later on we can, but right now we can't. So how can we answer this question? Well, I can use sign charts. I love sign charts. Starting at 0, my one critical limit, 0.443, and I'm going to look at the velocity. Now, I can tell by looking at the graph of my velocity that between 0 and 0.443, we are above that axis. So it's positive. And that's when we're negative, so it's going up and down. So take a look at this. Where is the only place that can be at a maximum height, and an absolute maximum for that? Yeah, it has to be at 0.443. It has to be there because I'm going up and then down, but do we ever go back up again? No. So this is what we call the only candidate. So we would say that the highest point occurs at t equals 0.443 because, and this is the weird part, because um, f whoops, I should say V of t goes from positive to negative. So I'm saying now that it is a relative maximum and it's the only candidate. So we are saying that this is what's called the only candidate rule right here. So what we're saying is that at this point right here, it is a relative maximum, but it's the absolute highest point because it's the only possible one because we never go up. So you got to kind of name both for that one. All right. Well, I hope you enjoyed the video. I will see you later.